Growth rings. Growth rings, also known as tree rings or annual rings, are rings that are visible in the horizontal cross-sections of the trunks of trees. In climates that vary by season or by year, they are the result of new growth in the vascular cambium, a layer of cells near the bark. This growth in diameter is also known as secondary growth. Changes in secondary growth in vascular plants are responsible for the formation of growth rings in the trunks of trees. Changing seasonal conditions, particularly temperature and sunlight, lead to differences in tree growth that can be traced by examining the growth rings. In areas with annual seasonal cycles, the tree rings can be counted to determine a tree's age in years, while in areas without particularly distinct seasons, a tree's rings may be indistinct or entirely absent. Each growth ring tends to be made up of two different parts, based on the growth conditions. Springwood, more commonly referred to as early wood, grows quickly in the growing season, usually in the spring or early summer, when the cambium produces numerous large cells with thin walls. Then, towards the end of the summer, growth slows down. The cells manufactured at this time of year are small, with thick walls. They form the summer wood, or late wood, which tends to be considerably denser than earlier wood and is generally darker in color. 1 year of growth is therefore represented by a ring consisting of a light part and a dark part. The darker wood is not formed in the winter, as some people believe, because the cambium is completely inactive in the winter. Trees from the same region will tend to develop the same pattern of ring widths for a given period. These patterns can be compared and matched ring for ring with trees growing in the same geographical zone and under similar climatic conditions. Following these tree ring patterns of living trees back through time, chronologies, a technique called cross-dating, can be built up, both for entire regions and for subregions of the world. Thus, wood from ancient structures can be matched to known chronologies, whereby the age of the wood can be determined precisely. Cross-dating was originally done by visual inspection until computers were harnessed to do the statistical matching. A cross-section of a tree shows much more than its age. Diameter growth is particularly sensitive to fluctuations in the environment, moisture in the soil and air, temperature, and sunlight. Therefore, growth rings, particularly annual growth rings, can actually provide valuable records of the climate conditions during a tree's lifetime. The study of climate change, as recorded by tree growth rings, is called dendrochronology. In certain cases, trees can live for many hundreds of years, and in an extraordinary case, like the bristlecone pine, thousands of years. Each year, trees add growth rings, which can indicate what sort of growing season the tree experienced. Extremely hot and dry years, or overcrowding, that limits the tree's ability to receive sunlight tend to result in smaller rings, while temperate conditions with plenty of sunlight and precipitation result in wider rings. Sometimes, multiple rings may form in a single year when excellent growing conditions alternate with distinctly bad conditions. There are almost no conditions in which a tree will not form a distinct ring during a year. One rarely recorded instance of a missing ring in oak trees occurred in the year 1816, also known as the year without a summer. There are also limitations to this dendrochronological research. Trees in the temperate zone only record the growing season, so the winter season, no matter how dramatic, will not be seen in the ring record. Interestingly, trees in tropical regions grow year-round, and, therefore, show no real, obvious annual growth rings. Therefore, climate data from equatorial areas is difficult to piece out and use. The record is limited geographically in another way too. Trees do not grow in all places on Earth. Therefore, we don't have a tree ring record of climate change for each region and ecologic niche globally.